Okay, day 2 of college algebra. Simplify the following expressions. Eliminate any negative exponents. So today we want to focus on perfect squares, perfect cubes, things of that nature, and then exponents. Perfect squares are 1, 4, 9, 16, 25, so on and so forth. What are perfect cubes? 1, 8, 27, 64, 125, so on and so forth. You can generate those. No, you don't get a nice little list. You can do it. Okay, we need to know those things by now. Simplify these expressions. So we want to simplify a square root. Can I just subtract these and get, say, negative square root of 192 or 182? No, that's absurd. What do I have to do? Simplify, and then the number underneath the radical has to be the same. So that's called the radicand. The radicand has to be the same. So we will first simplify them. Square root, minus square root, square root. Square root of 18 reduces to what? 9 times 2, and 200 would be 100 times 2. What do you know? I got 2 showing up there. That's great. So I've got 3 roots of 2 minus 10 roots of 2. And I get negative 7 roots of 2. Remember add and subtract radicals? Okay, we've been doing that for a while, so we just have basically one example on it. You try B on your own. That's a cube. I wrote the perfect cubes up there, so you can do B on your own. 12 cubed roots of 2. Is that right? Okay, so your perfect cubes were 8. 8 times 2 is 16. And then 125 times 2 is 250. Those are the ones we chose. If you have a question on problem B. Okay, problem C should be pretty straightforward. If I'm multiplying, I multiply the coefficients. What do I do the exponents? Add them. So whatever the operation is, that's what we always do to the coefficient. We do one step lower for the exponents. So that was easy. We try a more difficult one. So D, what do we do here? Okay, so you want to get rid of the negatives. That's fine. There's multiple ways to do this. You could do negative 5 minus 8 since you're dividing. What's negative 5 minus 8? Negative 13. So you know it's going to be 8 to the 13 in the denominator. But you guys don't really like that because many of you have done these problems in other classes. Your teacher said always move the negatives first. That's fine. I just want you to realize there's multiple ways to do these kinds of problems. So we'll go on. Let's see. There'll be a b to the 7th on top then. I think maybe even people drew arrows or something. Okay, there you go. Looks like I got an a to the 8th down there, an a to the 5th, and then a b to the 3rd. So now I've got b to the 4th on top, and I've got a to the 13th on the bottom. All right. Okay. On letter E, I would say that generally there's always a handful of people in class that get it wrong if they were to do it on their own. So we'll make sure we go through it. So make sure you ask if you have questions. But what do we deal with first? There's a lot of things here. Which one? Very good. So I'm going to use this. And do I bring the 3 to the front here? No, I just deal with what's in the parentheses, correct? So I have 3 times x y to the 4th times the quantity. What do I do with the 2? 2 times 3? 2 to the 3rd, which is 8. What do I do the exponents? Multiply. Power to power, multiply. So I get 12 y to the 9th. Okay, what do I do with that 3? Do I distribute it to the x and then to the 8? No, why? Okay, it's a situation here where a lot of people want to take 3 times 1 is 3, and then 3 times 8 is 24, then 3 times 24 will give me 72. A lot of people do it like that. But there's no addition or subtraction. If you had addition in between there, then you would distribute it across addition. But this is all multiplication. So as multiplication is written across, I just gather my coefficients towards the front. I have 3, 1, and 8. And those multiply to 24. And I gather my x's. How many x's? 13. I gather my y's. How many y's? Very good. If there was a plus or a minus in between there, that would be different. We distribute multiplication over addition and subtraction. Okay, letter F. What do you want to do first? You want to flip everything because of you don't like that -2. I agree. We'll flip everything. 2x to the negative third, y to the fourth, over x to the third, y to the third. Now what power? 2. So I used up that negative. Now, I would say that probably about a third of people would make a mistake in just that one step. What mistake would people make in that one step? What's that? Okay, all right, forgetting which ones were positive. What else? Jack, do you have your hand up? Yeah, a lot of people would take this x to the negative third and make it x positive 3. Why would you do that? Because you moved it. But when you move it, you do need to change it. But we didn't move it because of that negative. We moved it because of that negative. So we used up that negative. Okay, now let's use up this one. So we'll move that down. So 2y to the fourth over, let's see, x to the third. If I bring that down, that's going to make x to the sixth, y to the third. That quantity is squared. Go away. And then, now what? Okay, you could square it, or you could do your y's. So I've got 2y over x to the sixth. And now I square that. And Raylan is correct. We now need to square this. And so when you square it, you get 4 y squared over x to the good. And because we're in high school, we box our answers. Literally, I see fractions, and all of a sudden I get a headache and anxiety. Does that happen to anybody else? You see fraction, like, ugh, ugh. Not too bad. If you don't know how to do the problem, make an easier problem. That's what I always say. So if the problem looked like this, you'd say that's easy, right? You just have -10 a to the 7th, right? So let's apply the same rule. -2 times 5 is -10. A to the, well, I have to add the exponents. What do you think sometimes people do here instead of adding them? Multiplying. So to remind myself of what to do, I made an easier problem. So now I, just add them. In order to add 3/4 and 3/2, what do I have to do? Common denominators, so I got 6/4, which makes a total of 9/4. Now this is the correct answer. What if I were to write it as a radical instead of a fractional exponent? What would it look like? -10 times a root. What would I have? Which root is it? The fourth root, and be a to the ninth. This is incorrect. Why? It's not simplified. You could take out a perfect fourth out of here, can't you? Take out a to the eighth, and you get -10 a squared, fourth root of, you'll just have an a left over. This is correct. This is correct. That is not. If you did that on test, I'd take a half point off because it's not simplified underneath the radical. Just leave it like that. It's fine. Somebody said, isn't there a rule about not having like fractions in the denominator? No. You can have exponential fractions in the denominator. So for like y to the 3/2 over z to the 1/6, that's fine. What you can't have is 3/2 over 1/6. That you can't have. You have to multiply by the reciprocal and get rid of it. Different if it's an exponent with a base. Okay. How about h? What do we do? Well, let's start with the exponents because that looks like it's easier. Exponent to an exponent, what do? I multiply. 8 times 3 halves. 8 times 3 is 24 divided by 2, 12. 6. 6 times 3 is 9 divided by 2 is, or I'm sorry, 6 times 3 is 18 divided by 2 is 9. Yeah, that's what happens. And then what do you do to the 4? Do you multiply the 4 by 3 halves? No, you take 4 to the 3 halves. Well, taking 4 to the 3 halves, that's like saying the square root of 4 to the third, right? What is 4 to the third? Is 4 square root? 8 x to the 9th, y to 12. You try I on your own. Okay, I got 16x to the 4 thirds over y squared z to the 2 thirds. Let's talk about how we did that. I took the 2, not just 2, but also negative 2 to the 4th power, because it's in parentheses. So a negative to an even power will always give you a positive. A negative to an odd power will always give you a negative. So we have a positive, it's positive 16. And then the exponents, I take a power to a power and I multiply. 4 thirds, 4 halves reduces to 2, and 4 sixths reduces to 2 thirds. Okay, and we're done. Should I now take 4 thirds minus 2 thirds? Why? The bases are not the same. X and Z are not the same, so we can't do that. Okay, very good. All right, last 3 problems, and you get your assignment. You can have the rest of the time to work. Simplify the following expression. Square root of a to the 4th, b to the 7th, square root. So I need to separate it into 2 pieces. What is a perfect square that divides evenly into a to the 4th? A to the 4th. It leaves me with no a's left over. How about b to the 7th? I got b to the b to the 6th. And what do I have left over then? B. Anybody allergic to bees? Are you? All right. Got your EpiPen? Risky today. I like that. All right. Square root of a to the 4th, b to the 6th gives me a squared, b to the 3rd root of b. Good. Next one, we got cubed roots. What's a perfect cube that divides evenly into x to the 4th? So I have 1x left over. What's a perfect cube that divides evenly into y to the 8th? Y to the 6th. So I have y squared left over. Let's notice, people, if you have a square root, then it needs to be even numbers underneath there. If it's a cubed root, it needs to be numbers divisible by 3. Okay? So then when we take the root, we simply get x, y squared, and we get the cubed root of xy squared. Cool. And finally, our last one, C. What do you want to do? Do you want to start breaking them down, or do you want to multiply them together? I think that's a good choice. So we've got w to the 6th, b to the 12th. I take the square root of that. Yeah, w to the 3rd, b to the... Hey, that was easy. Now, you guys, I'm going to warn you that there's some problems in your assignment that they're trickier than this, okay? I could show you 100 examples of problems that involve exponents, and it wouldn't be enough, all right? You need repetition, you need practice. So you got some time in class today, you got the weekend. Make sure that you continue to work on the entrance worksheet, that you have that situated, ready to go. Check your answers over there. You need to visit back and forth, get help, that's fine. I would say that 3rd hour, probably ask me, probably a dozen questions during class. So Don't hesitate to raise your hand and check to see if you make mistakes. So your assignment is as follows. We have section 2.1, page 70, numbers 5 through 8. I think, oh, that's calculus. Never mind. All right, that's calculus. There we go. Section 1.2. Somebody told me today it's not actually page 22, it's page 23. I'm trusting that you'll be able to figure that out on your own. Sometimes in class, I won't know the page number. I just know the section. Like, I know the next section is going to be 1.3. People say, what page is it on? All right, so there's your assignment. So it says 23 through 55 odd, but odd is just put with those. And then these are all of them, okay? So I will definitely show you which ones are odd. And if odd isn't written after it, then it's all of them, okay? So make sure you keep that in mind. Practice, go.